Welcome, everyone. My name is Charlie Kolstad, and I'm delighted to welcome you to the Bits and Watts webinar, the third of a series on decarbonizing the grid. So why, in fact, are we focusing on electricity? Many of you that's obvious, but decarbonization, after all, is lots of sources, lots of areas that need decarbonizing if we're to reduce the CO2 emissions into the atmosphere, greenhouse gas emissions. And there really is quite a simple answer to that question. As we see in this circular graph of the source of greenhouse gas emissions by sector in the world, we see that the energy is about 3/4 of that. So that's an obvious reason why we would focus on energy. And electricity is also one of the easiest places to decarbonize. And one can simplify global strategy to reduce greenhouse gas emissions to really 2 steps. If you do these 2 steps, you've gone a long ways to decarbonizing our economy. So the 2 steps are, first of all, to electrify energy demand. And this is in transportation, this is electric vehicles, and in home heating, this is heat pumps. Other sources of heat would be heat pumps. A lot of areas in which one can electrify energy demand. And then secondly, decarbonize the electricity sector. And that's really the primary focus of these webinars, is the decarbonization of the electricity sector. And here's a graph that I like this graph quite a bit. This is an illustration for the US, but it could be done in any country, is what the nature is of our electricity generation by year the generation started in production. So if you note, there's some stuff back in the 1930s and 40s that's still running today. Coal-fired, small plants. And as you go through, you see this it's almost like a snake eating a piece of coal. You see the coal rising up, that's the darker bar in the 70s and 80s, and sort of tapering off in terms of new construction. The existing plants are still consuming it. In the 1990s, natural gas replacing it. Very heavy use of natural gas starting at the beginning of this century. And then we see, not long after that, renewables, the green, which is wind and solar, starting up and really taking off as we move into the last decade, which I guess is the teens. And that brings us to the present. Now, this data only goes to 2016, but a pattern is similar, except that a lot more coal plants have been retired. So this seems pretty simple. Decarbonize electricity grid, just put solar on everybody's roof, bunch of windmills up, and you're done. But it's not so simple. Electricity is a bundle of 3 things: energy, power, that's the rate at which you're delivering the energy, and particularly reliability. We're so accustomed turning the switch on, particularly if we live in Europe or North America, turning the switch on and the lights go on. And that's where the problem lies in decarbonizing with renewables. Renewables give us kilowatt hours, but the reliability 24/7 is a problem. I mean, it doesn't take a rocket scientist to realize solar is not working in the middle of the night. Electrifying demand also creates reliability problems, both locally and system-wide. Out here in California, it's not uncommon to have a block of houses, each person with an electric vehicle. And if all of them charge quickly at one time, which happens, there's tremendous stress on the distribution grid. That's not just the system-wide grid. You also have this curve that's shown on the right, which is fondly called the duck curve, because that's what it looks like. where it shows the belly of the duck sagging and almost going to drag on the ground because that's when a lot of the renewables are operating at full speed. And that obviously gives us the kilowatt hours, but at the wrong time of day. Where the duck's head is and where the duck's tail is, hardly any renewables or much less. Then you also have the issue of what happens when the sun begins to go down or the source of renewables starts to die down during the day. You need a rapid increase in other sources of energy. Well, this creates lots of havoc. With fossil fuels, everything's a lot smoother. Demand is the main source of fluctuations. Okay, so the solutions as we see it, and these are not trivial solutions, but the question is, how do we decarbonize with reliability? The four wings of this solution, and these are also the themes of our webinars that we've been having. One is to expand interconnection between regional or local level. This is just like insurance, in order to take into account the fact that fluctuations are occurring differently at different geographic locations. If we can connect them better, then we can buffer those uncorrelated shocks. But in many countries, transmission lines are notoriously difficult to permit and construct. And I'll have an example of a solution, a policy solution to that in a minute. Another is storage. If we could just put that solar in our pocket that happens midday and pull it out of our pocket in the middle of the night, we'd be home free. Those storage costs are high, a lot of technological progress there, and the interface with generation may be difficult. The third is to develop policies to facilitate decarbonization of supply with expanded demand. For instance, a big problem in decarbonization is the coal industry. A lot of jobs, a lot of poor areas involved. Many countries have had the problem of phasing out an industry. Incentives to help phase out coal in a way that helps people can do a lot. And then finally, better coordinating demand side flexibility. Us economists always like to price everything, but there are other ways or ways to augment pricing to create demand side flexibility. Okay, so here's that example I was talking about. These are, the green is the Midwest power pool in the US, and the orange is the PJM power pool. These are relatively big power pools, and a lot of the wind is in the Midwest and a lot of the demand is in the PJM area. So how do you construct a long distance transmission line? Well, the policy solution is to go where there are already transmission corridors owned by single entities, and that's the railroad right-of-ways. And this project is putting a DC, high voltage DC power line along a right-of-way from the middle of the Midwest to Chicago, which obviously is a valuable and creative solution to this problem. Okay, that brings me to our presentations. We're really delighted to have four scholars with us here today who are very active in this area. And I'm going to introduce each of them in turn, and this will be the order in which they'll speak. They'll each speak for about 10 to 15 minutes, and then we'll follow that by Q&A. So first of all, Professor Steve Pacala, Princeton University. He's the director of the Carbon Mitigation Initiative there. He also has a close connection to Stanford. That's where he went to the university. He's also on the board of directors of the Precourt Institute of Energy, of which Bits and Watts is part. And relevant to today's webinar, He chaired the National Research Council, National Academy of Sciences recent study, which resulted in a report just a few weeks ago in February entitled Accelerating Decarbonization of the US Energy System. And he'll have some words on that in a minute. But let me introduce everybody before we turn to Steve. Professor Chris Knittel. He is the director of MIT's Center for Energy and Environmental Policy Research, affectionately called CEPR. Now, this is MIT's CEPR, which I have to tell the Stanford people, we have a CEPR as well, but it's spelled differently, SIEPR, Stanford Institute for Energy Policy or Economic Policy Research. The MIT one came first. And it's been active for many decades, since the 1970s in this area. We're really pleased Chris is joining us. Professor Richard Green from across a couple of ponds from California, but across the Atlantic in London. He has extensive experience with electricity regulation in the UK and is a professor currently at Imperial College Business School, which is part of the University of London, which is a very large university. So many of the colleges in London that we think of as independent schools may be independent, but they're mostly part of the University of London. And then finally, my colleague, Professor Larry Goulder. He is the director of the Stanford Energy and Environmental Policy Analysis Center, which is part of the Stanford CEPR, not the MIT CEPR. And he's had a long history of authoring in this area, most recently a book on confronting the climate challenge, options for US policy, published in 2018. So without further ado, let me hand the podium over to Professor Pacala.
Good morning, everyone, or good day or good evening, depending on where you are. I'm going to be giving what amounts to an abbreviated briefing on this report that was released, as Charles said, on February 2nd. And it's the first of two reports from the National Academies of Sciences, Engineering, and Medicine, the three academies combined, on accelerating decarbonization in the US energy system. The second report will come out in a year. The scope of this first report is that it's about federal actions over the next 10 years to put the US on, and I want to emphasize this, a fair and equitable path to net zero emissions in 2050. Now, the fair and equitable piece is unusual for an academy study. So this is about the social factors that are involved in the transition. Usually in the US, we throw legacy workers under the bus and move on. But there is a substantial discussion on both the right and the left that not to do so this time. I can tell you that since releasing this report, in the many, many sessions I've had with Congress and other branches of the federal government, that the two issues that come up the most, it's not cost or anything else or feasibility like you might think. It's number one, what about the fate of the fossil fuel aligned workers? Everybody from, someone who works in a fossil power plant now to someone who works in a refinery and so on. And second, what about the environmental injustice that is built into our current energy system? We can't allow that to continue. And this includes, for example, the fact that historically marginalized and lower income Americans suffer disproportionate exposure to fossil pollution, but get disproportionately low benefits from the energy system in exchange. So the panel that we put together has at least half social scientists. It's only half sort of technical people. So this is the only, I've been involved in a couple of these now, and this is the only study I know that has as much ink and as thorough a policy portfolio on the social side as it does on implementing the technical side, building the hardware. All right, so This report includes just CO2 from transportation, electricity, industry, buildings, and biofuels. We weren't asked to determine whether or not the nation should move to net zero, only how to get there, and other greenhouse gases and sinks created by nature-based solutions, forestry and cropping practices aren't discussed in detail in this report, but will be in the next, and it's broadly compatible with recent announcements from the Biden administration, but it was developed by a panel independently. Now, I want to turn immediately to the key findings and recommendations from the report. I won't have time to provide you with all of these, but I can orient you around a web resource that I'll show you the address to in a second that will allow you to understand everything in the report really quickly. It's a reconfigurable table that has everything that we recommended in it. I want to say that we did try, and I think succeeded in reading everything that was written on this subject, certainly in recent years, and took testimony from most of the studies that were in progress. Now, the technical side of the recommendations are organized around 5 different technology goals, each signified by a different icon, and the icons turn out to be important. And each icon, each technology goal also has a long list of quantitative targets associated with it. So the lightning bolt is, as Charlie just said, electrify energy services in transportation, buildings, and industry. And an example includes moving half of vehicle sales, all classes combined, to EVs by 2030 or deploying heat pumps in a quarter of residences. I should say also that this first report focuses only on the first 10 years of a 30-year transition. So these are the federal policies that would be needed to be enacted like pronto to get through the first 10 years of a 30-year transition. So this target is for the 2020s, all right? So by 2030, you'd want to have half of vehicle sales, all classes combined, be EVs. The light bulb with a leaf in the middle of it is improve energy efficiency and productivity. And there's a whole list of targets associated with this. The biggest efficiency gains come actually from electrification of vehicles and heating. The wind turbine and the solar panel means increase the production of carbon-free electricity. We need to roughly double the share of electricity generated from carbon-free sources in 2030 to around 75%. The little gears driving ever bigger gears means expanding the innovation toolkit. We need to triple federal support for net zero RD&D. That tripling is not a generic top-down tripling. That's a bottom-up analysis. Most of the technology that we need for this transition, and all of it that we need for the next 10 years, is already in the quiver. But there are sectors that include, industrial sectors like cement production and steel, and transportation sectors like aviation and shipping, where solutions are still pre-commercial. And so we need a big expansion in RD&D to bring those technologies in, much the way that public policy made wind and solar the cheapest levelized source of electricity of any source over the last 30 years. The transmission tower means that we need to plan, permit, and build critical infrastructure, including new transmission lines, an EV charging network, and a CO2 pipeline network, which is necessary even if you're shooting for a 100% renewable system in the end. I should also say that one of the encouraging things that we discovered by looking at all of the different paths to decarbonization is that the actions that you need during the 2020s are essentially independent of the makeup of the net zero energy system in 2050, be it 100% renewable or retaining substantial amounts of, say, nuclear and fossil with CCS. So this is a fight we don't have to have now. We also have 4 socioeconomic goals. The American flag means strengthen the US economy. We have policies to reinvigorate US manufacturing, to protect export exposed businesses from a carbon price early on, and to try to increase employment, particularly of blue-collar jobs. The community with the road through it is a proactive support of those adversely and directly affected by the transition. We have a portfolio of policies designed, in fact, to proactively address job losses and other disruptions, and to come, and also to distribute benefits even fairly, and also to allow communities to participate in that planning. The people holding hands is promotion of equity and inclusion to ensure an equitable distribution of benefits, risks, and costs, and so on. And the piggy bank means maximize cost effectiveness, all else equal. So the policy recommendations, there are 30, and they're in a single table. And the table is available at that website. And if the organizers of the webinar could post that on the chat that everyone can see, that would be great. The first column shows the policy. The next column shows the icon, the technology goal that the policy is intended to address. The color of the icon, the darker it is, the more essential that policy is to achieve that goal. The next column is the socioeconomic goals. The next one is the government entity responsible for executing the policy. The next one is the appropriation, if any, that is needed for the policy. Before anyone asks, without revenues from a price on carbon, these policies total $350 billion in appropriations cumulatively over the next 10 years. And finally, there's a notes section. So there's lots more in footnotes and so on. But if you go to this website and look at this table, you can click on the various icons and it will give you a custom table specifically targeting a specific goal. So if you click on the transmission tower, it'll show you all of the policies in prioritized order required to build the infrastructure, all right? So I'm gonna show you 12 of the 30 policies in the 4 minutes I think I have left. We recommend that the US adopt a formal emissions budget that is granular by sector. You need other policies, obviously, to enforce this, but without an emissions budget going to zero, we won't know where we are. We recommend an economy-wide price on carbon starting at $40 a ton and rising at 5% per year. We also recommend additional policies to soften the impact of this on low-income groups, and also to soften the impact on import-export exposed businesses. But $40 a ton, even so, isn't enough to do the full transition. To do one of these transitions, you have to replace long-lived capital stock as it ages out, and some of it ages out immediately. And some of those initial replacements with a non-emitting alternative or with an alternative that is easily retrofit are expensive. And so we didn't propose a carbon price large enough to do the full transition because there isn't an economics literature that shows you how to do that in a fair and equitable way. The literature kind of tops out at about $40 a ton. So that's where we ended. We propose a national transition task force to assess the vulnerability. The literature on who's going to be hurt by a transition is not complete, and we need a formal census and assessment. We propose a formal office in the White House to track how equitable the energy transition is, to monitor progress, and to enforce it across the federal government. This goes beyond the office that the Biden administration has recently announced. If you want to keep from leaving legacy workers under the bus, and if you want to fix what's unfair in the current energy system, we need eyes on this at the top and a serious effort. We propose a national transition corporation, which is the primary source of aid to communities that need it, all right, that want to attract an alternative business to a fossil employer they're going to lose, that want retraining and that sort of thing. We also propose 10 regional centers that coordinate planning and administer block grants to communities with technical assistance from other branches of the federal government so that they can plan and anticipate and know what to propose to this National Transition Corporation. We proposed a green bank capitalized at $60 billion by 2030 to free up the capital that is required where our current capital markets aren't designed for the transition. We need a comprehensive set of education and training programs that you can read about. As I said before, we need a tripling of net zero RD&D. And we also propose a series of standards because 40 bucks a ton isn't enough for the full transition. A clean electricity standard designed to reach 75% of zero emissions electricity by 2030. We also propose regulatory reforms to be able to site the transmission for these facilities. And these is absolutely critical. Without those, you're not going to do it. You're going to end up with CO2 pipelines and decarbonized fossil if you want to get to net zero, or nukes if you don't figure out how to site the electricity transmission. We need standards for zero emissions vehicles, and we need manufacturing standards for zero emissions appliances, including heat pumps in buildings. So the full report is available at the top website. The policy table is at the middle one, and there's also an interactive summary at the bottom one. And I think I have, because I started late, I think I have 1 minute. So I'm going to use it to give you one finding that surprised me. This is the fraction of GDP in the US that the US has spent on its energy system since 1970. And there we are currently. And these are predictions about the transition to net zero that are now in the literature from studies, and alongside some business as usual trajectories. And the important take home is this: to transition to net zero, the US economy will have to spend a smaller fraction of its GDP over the next 30 years than it has over the last 30 years. And so by this metric, that's affordable. It does require a lot of capital, but that capital requirement is not a cost. In the same way that any capital, its operating costs also matter, right? So renewable electricity has high capital costs, but it's got a lower levelized cost of electricity right now because you don't have to pay for fuel once you've built it to make electricity. Finally, this is a jobs analysis for predicted job losses and gains in every state. If you look at this carefully, there are exactly, I think, 5 states with even transient losses in jobs. That's West Virginia. You can see the coal jobs disappearing. So the employment picture here is restricted regionally, and I think is perhaps possible to address by policy, where we might locate industrial hubs in places that are going to lose particularly oil and gas jobs, like down here on the Gulf Coast or up here in the northern Midwest. So I'll leave you with that and turn the mic over to the next speaker.
Thank you, Steve. Chris.
Great. Well, thanks for having me. And in a remarkable twist, my presentation is going to be actually quite consistent with the proposals that Steve just made. It's going to be different in the sense that I'm going to do a little bit of a deeper dive into 2 of the policies that Steve mentioned, and in particular a dive into mixing those 2, and that's a clean energy standard or a renewable portfolio standard with a carbon tax. And I'll be discussing some recent work of my own out of, as Charlie said, the MIT Center for Energy and Environmental Policy Research. So I really have one goal in my 15 minutes, and that's to convince you that policy choices matter. And you're already at a webinar about policy choices and decarbonization. So I guess to sharpen that goal, it's to convince you that they really matter. And they really matter across 2 spectrums that I'm going to focus on. They matter in other ways as well, but I'm going to focus on economic efficiency and the distributional impacts of those policies. And like I said, this is drawing from 3 recent papers of mine that I put here in case you want to dive deeper into the analysis. So first, in terms of what does the economics literature tell us in terms of policy choices? Well, it already tells us that policy choices really matter. So I'm really replicating a lot of literature that's already been done. And to put numbers to it, a lot of work has been done, for example, in the transportation sector, looking at how you can get reductions in carbon emissions through either a fuel economy standard or a carbon tax. And Larry's done some great work in this arena as well. And that literature suggests that these alternatives to a price on carbon are often as much as 10 times more expensive than getting those reductions from a price on carbon. And that's on an apples to apples basis. So it's this either starting at the same point and getting to the same point. Using standards can often be 10 times more expensive than a carbon tax. And we actually see that in data right now. Since I'm presenting in California, I took these data, recent data from California. Right now, California has two policies to reduce greenhouse gas emissions from transportation. One is the low carbon fuel standard and one is the cap and trade. And the low carbon fuel standard prices are trading at about 10 times the cap and trade prices. So now what I want to do is transition from transportation and think about what this means in the electricity market. And look, I'm not an ivory tower sitting person that ignores the politics. I understand that carbon taxes or a price on carbon is a heavy lift politically. I view my job as educating policymakers as to what the trade-off is. So they can obviously do the trade-off in terms of the politics of putting their weight behind a price on carbon or a clean energy standard. I can't do that for them, but what I can do for them is tell them what they're giving up if they're moving from a price on carbon to a clean energy standard. And that's, again, what I view my job as being in this front. Some of my recent work, though, has been getting at what's something that Steve brought up, which is we might think we want both. So not only do we want a price on carbon, but we might be worried that that price on carbon might not be large enough to get us all the way to where we want to be. So we can augment that with a clean energy standard. Or conversely, we might all think we're going to have a clean energy standard. We might also want to know what the marginal benefit or what the benefit of a small marginal carbon tax is on top of that clean energy standard. And that's the topic of a recent paper with Emil Demonchev that I'm going to show you some graphs from. So we do replicate the existing literature there showing how much cheaper it would be if we did everything via a price on carbon. But unlike the literature, we also look at in-between cases. And the punchline, just to jump to that, is a wimpy carbon tax goes a long way in terms of cost reductions. That you can get a significant amount of cost reductions from just having a little bit of carbon pricing on top of that clean energy standard or a renewable portfolio standard or whatever electricity standard you want. So what we focus on here is the middle case here, where, as Steve mentioned, we might have a $40 price on carbon. That's not enough. So we need a 100% clean energy standard on top of that, or a 75% clean energy standard. And the way we're going to do this is use two models that we have at MIT. One is the first one is an economy-wide model run out of the MIT's joint program for global change. And that's, if you're familiar with the term, an integrated assessment model. So it has a model of the macro economy, it has a model of the climate at a very large scale over hundreds of years. And then the second is MIT's effectively resource planning model for electricity markets, and that's called GenX. And we've been developing that over the last decade or so. So this is a highly resolved electricity model where we have hourly electricity demand over an entire year's worth of electricity demand. And the model is optimizing the mix of technology to invest in to get to a certain carbon goal, meeting all of the constraints of the transmission and distribution system inside of the model. Our results are for New England, but we've run this model for ERCOT, California, PJM, and other markets as well. So before I show you the results, just really quickly, where are the benefits coming from carbon pricing? and this is going to vary depending on which model we focus on. So because the EPA model is an economy-wide model, it can find the least cost carbon reductions outside of the electricity sector as well. So that's one. That's going to be shut off in the Gen X model because Gen X is just looking at the electricity sector. The second big benefit of carbon pricing is, as everyone knows, as you start to really decarbonize, the marginal cost of that incremental decarbonization gets really steep, especially after about 90%. That hockey stick cost curve starts to shoot up. So what a price on carbon does when you're adding it to a clean energy standard is allow for demand reductions and allow us to not have to travel as far up that hockey stick as we otherwise would. And then the third depends on what alternative you're thinking about. And in particular, imagine a clean energy standard versus a renewable portfolio standard. How are they different? Well, typically the clean energy standard allows for nuclear and the RPS doesn't. So a carbon price on top of a renewable portfolio standard might incentivize more nuclear facilities to stay online, absent any additional policy. So here's the punchline. And let me explain this here. So what this is the costs associated with getting fully decarbonizing the grid only through a renewable portfolio standard. These next dots here are, well, what if we only used 95% or only use the RPS to decarbonize 95% of the way there and added a carbon tax to get the rest of the 5%. And the y-axis is the relative costs of doing that. So what we find is that just backing off a little and relying on a price on carbon for that last 5% reduces costs by as much as 65%. Relative to doing everything through a renewable portfolio standard. And the marginal benefits of relying on carbon pricing wane because as you go down that hockey stick, the marginal benefits of going down that hockey stick get smaller and smaller. So what this suggests is AOC's wimpy carbon tax actually has a lot of power, that we can cut the cost of decarbonization in half by just having a little bit of carbon pricing on top of a renewable portfolio standard or a clean energy standard. So I'll just tell you, for the Gen X economy-wide model, it looks very similar. There, because it has transportation, we can look at fuel economy standards versus carbon pricing as well. But the end result is a little bit of carbon pricing goes a long way. Let me end my last couple minutes here talking about equity. So some other recent work that I've done, and this is actually the wrong paper. I can put the correct paper in the chat. But as part of a research initiative between MIT and Harvard, led by Ernie Moniz, we've been looking at a just transition and how to do just like Steve mentioned, which is how can we transition the economy without leaving certain groups behind. And as part of that work, one of my papers looks at carbon footprints across the US at a very fine geographic area. So we look at average carbon footprints for a census tract, and there's 75,000 census tracts across the US. And what you get is a very striking picture. So these are average total household carbon footprints for all of those 75,000 census tracts. And what jumps out at you here is that the middle of the US has very high carbon footprints. And we're both on the coast, we sort of understand that already. But what that means is that we have to be very careful how we decarbonize, because a lot of that burden might fall on the shoulders of middle America. And politically, that, to me at least, suggests it's not going to happen. And even if it does happen, it's our mission to keep it from adversely affecting middle America relative to the coast. Now, what this also means is that suppose we did have a price on carbon, if we just, and I think the most popular price on carbon would be a tax and dividend plan where we would generate a bunch of revenue and send it back to the households on a per household basis. Well, what this picture means is a lot of money under that plan would flow from middle America to the coast because middle America would be taxed more on average and the coast would be taxed less. So the coast would make money and the middle America would be spending money. And that's what we show in the paper. But what we also show is that you can adapt how you structure the dividends to guard against that. So the top graph there is our preferred carbon tax and dividend plan, where the dividend checks depend on whether you're in an urban environment or a rural environment, and also vary across the 10 census regions in the US to guard against the money flowing from middle America to the coast. But what I also want to stress is the carbon tax on an equity framework is much better than the alternatives. Why? Because you generate money and you could actually undo some of the things that you don't want to see happen. Whereas a clean energy standard doesn't generate any money. So if you had a national clean energy standard that was just based on households' carbon content of their electricity, that too is going to send a bunch of money from middle America to the coast, and there's going to be no revenue generated to undo those effects. So what I've been trying to educate policymakers on is that it's true that a carbon tax can be regressive and can be unequitable from many standpoints, but it generates money so you can undo those things if you wanted to. So just wrapping up, what we've shown in recent work is carbon pricing has huge efficiency benefits and distributional benefits. But another thing that we want to stress is that a little bit of carbon taxing goes a long way. And that's it, Charlie. Thanks.
All right, Chris, thank you very much. I love your choice of position on the screen too, down in the corner. Our next speaker is Richard Green.
I guess I'm the token view from Europe. So good afternoon, everybody. And I'm Imperial College Business School. Imperial College London is effectively the UK equivalent of MIT. We are actually a full university because we declared independence from the University of London and give our own degrees a few years back. But I think the University of London still exists in some sort of nominal form. They just don't have any power. That's a good way to keep central university administrations. So anyway, given that 52% of my electorate thought I shouldn't be allowed to speak for Europe, I'm actually only speaking for Britain. And I was at an event at another place in the Bay Area that I suspect I'm not really allowed to name yesterday, and saw from that US electricity emissions have come down 25% in the last few years, which is pretty good. I'm afraid ours have managed to come down quite a lot more than that, particularly over the last 8 years or so. We, like you, had a dash for gas. Yours was in the early noughties, ours was in the 90s. And so that helped get rid of some of our emissions. And if you asked the average member of the great British public, what have we been doing to electricity recently? The data go from 1990 to 2019. I think the rest will probably be okay, although you'll miss a couple of references. So if you asked an average member of the great British public, what have we done to electricity? The question would they'd probably say, well, we built a lot of renewables, wind farms and solar panels, but actually a whole range of other policies have gone up. And it's a potentially interesting question to disentangle them. And the standard way would be to run a model and say, well, what if we hadn't had renewables? Or what if we hadn't had a carbon tax? But the problem is, if you add renewables to an electricity system that's almost entirely fossil, it will have a big impact. If you add a carbon tax to a system with no renewables, it will have a big impact, but you shouldn't really do the double counting. So what Ian Steffel and myself have done, looking between 2012 and 2019, has actually been, firstly, we took account of the small change in the weather, because 2019 was a little bit of warmer in the winter, so less heating, less demand, perhaps a bit sunnier, perhaps a bit windier, so more renewable output, and therefore slightly lower emissions, even if nothing else had changed. And then we calculate Shapley values, looking at all the other things that could have changed, but looking at the marginal contribution in all the different orders that they might have happened. So our fossil capacity changed. We started by reducing coal capacity, not to deal with carbon emissions, but to reduce emissions of sulfur dioxide, the EU's Large Combustion Plant Directive. We subsidized some stations to convert from coal to biomass, drawing their biomass, I believe, mostly from the United States. And then some other coal stations have since closed. We also added a lot of subsidized renewable capacity. Offshore wind has grown a lot recently, onshore wind less significant and earlier on. Solar PV has also grown quite a lot of gigawatts, but not nearly so many terawatt hours. We have had two carbon prices. The European emissions trading system started up in 2005, and this is the incremental effect between 2012 and 2019. By 2019, it was actually at a sensible level, but for most of the period, it wasn't very high. And we then had our own UK carbon price floor added on top of that, which had a decent impact on emissions. Fuel prices, coal got a bit cheaper, which was bad news. Gas got a lot cheaper, which was good news in terms of emissions. And then our demand has fallen, partly because the British economy keeps not doing very well. And this was before we got to 2020, of course, and COVID, partly because of policies to promote energy efficiency. And so that has about 20 million tonnes worth of emissions reductions. We have also increased our imports by building new interconnectors and using them more intensively, partly because the carbon price, the British carbon price, made our fuel price, our electricity price go up, and therefore makes importing from a country that doesn't have it more attractive. We're using national carbon accounting, which means that emissions don't count if they're over the border, but actually the European systems we're importing from aren't particularly high carbon. France has an awful lot of nuclear power, and so the impact isn't that huge. And then unfortunately, we have been shutting some of our nuclear stations, so that's moved in the wrong direction. But basically, we have had a large number of different overlapping policies, and they've all had quite an effect. And of course, in a similar vein to Chris's presentation, you could ask, well, did you need them all? Could you just have had one instrument? And it's been suggested to us that all we really needed was a carbon price. And for that, I'd like to sort of use a version of a diagram that comes from Michael Grubb of University College London. Again, says it's a college, but it's a full-size university. And he points out that where you want firms in particular to make optimizing economic price choices to get to cleaner products, cleaner processes, then markets and prices are a very good way to get there. So the carbon tax works for getting electricity companies to switch between coal and gas stations. On the other hand, and I say this comes from the book Planetary Economics, which is Michael Grubb plus Christian, I think, Hurkard and Carsten Neuhoff. And so it's a nice presentation, but they point out that there are actually three domains of decision making. So ways in which we make decisions, types of policies, and what we're trying to get from them. And while firms may make optimizing economic choices quite a lot of the time, there are other decision makers, us, who very often just make satisfying behavioral choices. You won't buy the energy efficient fridge, particularly if you don't actually know it's more efficient. You won't buy the low energy light bulbs, even though they're going to save you a lot of money over their lifetime. And Michael has a very good story in the book about how long it took him to insulate his loft and cut his energy bills that way, even though at the time he was the chief economist for the main UK policy body charged with delivering energy efficiency. And then that's not enough. We also need to transform our infrastructure. So some very significantly different investment choices, some of them using technologies that don't really exist yet. And so for those choices, Michael suggests markets and prices will do a little, but not that much. So Michael suggests that standards, intelligently designed, so not necessarily completely overlapping fuel standards or sort of perhaps vehicle economy standards that I believe don't actually count sports utility vehicles, if I've got that one right, and forgive me if I haven't. They can do a lot to help people make smarter choices, and they'll help a bit with the economic choices. They probably won't do much on investment. And then strategic investment policy, research and development, demonstrator projects, support for the early wave of any new technology, such as some of the renewable generators, that will help transform the innovation and the infrastructure. So that is someone else's framework, but I think it's a good answer for why you do need a mix, whether it's the standards and the investment to supplement your carbon price, or whether, as Chris was saying, it's the carbon price to supplement the standards for renewables. So on that, I'll thank you. I'll give you the reference for my own joint work that was most of what I was talking about, and I'll hand over to other people. Thanks very much.
Thank you very much, Richard. So our last speaker, Larry Goulder, I'll hand it over to you.
I think there's been a terrific set of presentations already, and appreciate being able to contribute. To expand the geographical scope, I'm going to be talking mostly about decarbonization in China, and lead off by indicating an announcement made last September by Xi Jinping, saying that China will aim to have CO2 emissions peak before 2030 and achieve carbon neutrality before 2060. Well, how serious are they about that, and will they get there? First, as you probably know, China now has the invidious distinction of being the world leader in CO2 emissions, reflecting its very, very significant economic growth over the past decades. It's now contributing a very large share of global CO2 emissions. This is from 2020. Over a quarter of the emissions, CO2, come from China. And where are those emissions in China coming from? A large fraction, almost half, are coming from the power sector. So if we want to talk about electricity and you want to talk about decarbonizing, focusing on China's power sector is a relevant place to focus. What about that power sector? Where are the emissions coming from? Well, this chart indicates that a large fraction of the CO2 emissions from the power sector in China are coming from coal. They, as you know, very reliant on coal-fired electricity generation. And as we'll see, they're still constructing a significant number of new power plants that are coal reliant. China is, despite making a lot of progress, it still remains very carbon intensive compared to the rest of the world on average. It generates about 1 megaton of CO2 emissions per $1,000 of GDP. And that's much higher. It's about 60% higher than the global average. So there's a lot of way to go, but at the same time, there's a lot of opportunity. So I'm going to be focusing on this. Some of my own research in recent years has focused on some innovative approaches that China is taking to reduce CO2 emissions. And overall, I'm actually encouraged. So what are they doing? How can they get there? Well, they've introduced very recently, within the last few years, it's just now being implemented, a emissions trading system, which will stand to make very significant reductions. It's a nationwide emissions trading system. Because it has the word trade in it, it's sort of going to harness market forces. And because it's nationwide, it has the prospect of exploiting or picking the low-hanging fruit because it's very broad in its base. It's expected to be the largest in the world once it's fully implemented. It will more than double CO2 covered by emissions pricing worldwide after full implementation. It could contribute to about half of China's CO2 emissions reductions. It's not the only measure, but it's a very important measure. And it basically succeeds what had been since 2011, 7 municipal or regional pilot programs. And now we're moving to nationwide. I'm going to focus on impacts, some of my own work in the initial phase, which is just starting up now and will last about 2.5 years, which concentrates on the power sector and covers about 2,000 power plants, basically virtually all of the power plants in China. But this program will later expand to cover basically most of the industrial sectors in China, cover 8 large industrial sectors, most in terms of actual amount of production. So what's China's approach? We've all heard of emissions trading, but it's not going to be cap and trade. It is a different approach. It's a tradable performance standard, which is an intensity-based approach. Basically, to meet the standard, to comply, the ratio of emissions, let's say of a power plant, to its production of electricity, that ratio has to be below some ceiling. It's not a constraint on absolute emissions, it's a constraint on the ratio. That makes a whale of a difference. So it's not cap and trade. And recognize what that implies is that under cap and trade, except in some cases like output-based allocation, basically the covered facilities face a fixed cap. They have to keep their emissions in absolute amount within a compliance period below some given number. In the case of a TPS, tradable performance standard, it's different. Now what counts is keeping the ratio below some number. So your absolute emissions are not controlled, and this has powerful implications. Let me just explain in words what that means. What the regulators do is they set these things called benchmarks, which is for different classes of technologies. They select what they feel should be the ceiling or the emissions output ratio that is justifiable, that is needed for compliance. Those benchmarks can differ by facility or by type of technology. And what this means is that then the regulators in each compliance period, they see how much electricity is produced by a given generator of a given technology type. And they say, okay, given that amount of electricity, here's the amount of emissions you're entitled to so that your emissions output ratio would be within compliance. If you don't have enough, if you have too much emissions, well, then you have to buy some allowances or you have to figure out a way of reducing the intensity. So the key thing here is, and I mentioned it here a little bit more mathematically, but this is basically the idea, is that once the benchmark is chosen, a firm can affect how many allowances it gets by the amount of output it has. What's really critical is the ratio of emissions to output, not the absolute emissions. And this has profound implications, I would argue, and some simulation results suggest that's the case, that relative to cap and trade, very different implications. Okay. I also, in sort of in the spirit of talking about fairness, which was an issue that Steve brought up, and also Richard, and indeed, so did Chris. This choice of benchmarks is really much based on political considerations. If there's politically powerful power plants that are highly energy or emissions intensive, they get oftentimes more relaxed benchmarks, that is higher standards or higher ceilings. Whereas in other places, the ceilings are tighter. And so this is often predicated by political considerations and some considerations of fairness. Choice of benchmarks is very important. So there's strengths and limitations of this approach. Limitation, as I'll try to demonstrate in a moment, is that it's less cost effective. And the reason is, intuitively, it's this. One of the ways under cap and trade that you can reduce emissions is by reducing your output, reducing your level of production, say your level of electricity. That can help keep you within, you won't have to buy as many allowances. In the case of the TPS, in a sense, you lose something by reducing your output as a way of complying. You don't get as many allowances because allowances are, for a given intensity, proportional to your output. And that means that it's less cost effective because the channel of reducing emissions that's employed more effectively under cap and trade, namely reducing the quantity of intended output, isn't exploited as much. On the other hand, there are several attractions. There's an implicit subsidy to output under the TPS. And as a result, electricity prices tend to be a little lower, and that's a powerful issue politically in China. Better for electricity consumers. Less leakage, because electricity prices go up less, it's less likely to lead to higher levels of output elsewhere in other jurisdictions, which would contravene the intended effect, which is to reduce emissions. Also, because it's an intensity approach, the business cycle, there's kind of an automatic adjustment. If the economy is booming and electricity production is really high, that doesn't necessarily mean you're going to be out of compliance as long as you keep your emissions output ratio at the right level. Whereas under cap and trade, in boom times, you increase your output, you're going to hit much harder against that fixed constraint. There's also the issue of familiarity in that in China, they're used to focusing on intensities, on ratios. In fact, their 5-year plans are often in terms of pollution per unit of GDP. So there are attractions as well. What I want to just show you quickly is what difference it might make relative to cap and trade. And although I'll mention some liabilities here of the TPS relative to cap and trade, I just want to suggest, I think this is a major step forward. Broad-based, economy-wide, exploiting market forces. I think it's very exciting. But anyway, under the TPS, you notice that only about a quarter of the emissions reductions, and this is for the year 20, in our benchmark year, 2020, only about a quarter of the reductions are accomplished by reduced output. Over half is accomplished by reduced heat rates or lowered emissions intensities. Now, all of these things need to contribute, but it's relatively less efficient because in contrast, under cap and trade, about 3/4 of the reduction of a comparable cap and trade system with the same scope and the same stringency, about a quarter of it's coming through reduced output, which is a more efficient way to go, and much less is coming through lowered heat rates or emissions intensities. And that translates into what you see here, where in a numerical model, a computer model that also generated the results in the pie chart just before, what we see is that under the TPS, for any given amount of emissions reduction, and that's going to depend on the benchmarks, how strict they are, it's going to be, according to our calculations, almost twice as costly or even slightly more costly to do it under the TPS relative to cap and trade. For some of you who might detect that there's a nuance here, which I've ignored, which is that some cap and trade resembles the TPS in that it has so-called output-based allocation. That's usually a small part of a cap and trade system, but to the extent that cap and trade has that, it's going to resemble more TPS, and this line here will have to be shifted up. So I've, in a way, put cap and trade in its best light the way I've described it here. But big difference, and this is the stringency. Let's see if I can get the pointer to look. This is what seems implied by the benchmarks that the Chinese planners are now considering. And one thing to mention is it's only going to imply, and I guess this got a little bit out of sync, this 4.9% or 134 million ton reduction, that's the reduction in the central case, which is, a step forward, but it's not exactly a huge reduction over the next 2-3 years. So China would have to ramp up quite a lot in order to get down to the 2060 target. So that raises the last thing I want to focus on, my last 2 or 3 minutes. What more is needed? Well, just put this in context. China is continuing to commission a lot of additional coal-fired capacity, even up through 2020. In some sense, more than much of the rest of the world. So what's going to happen? And here are the here's the projections for 2050. Compared to what would happen if we continue on a BAU path, coal's going to have to be reduced quite a lot relative to current. How will it get there? Well, the TPS does encourage renewables. So maybe one thing we have to think about is renewables. It already does that by raising the cost of fossil. But the TPS is going to have to be a lot more stringent in order to get anywhere near or even to approach the 2060 goal. China is also directly promoting renewables by a couple of ways. One is by purchase guarantees for renewables-based generators to the extent that they're concerned about whether there's actually a market. They can be guaranteed of it, the demand. There's also compensation for those renewables-based generators like wind and solar, some of whom have faced curtailments. There's financial compensation. Importantly, other direct approaches for renewables have been scaled back since 2014, like feed-in tariffs and direct subsidies for solar and wind. Why scaled back? Political pressure. Because the extent that solar is making a serious inroads in certain regions or provinces, it's affecting the price of electricity by basically discouraging what's cheaper, at least on a private cost basis, which is fossil-based electricity. And China's been uneasy about that. So they've actually scaled back a number of their renewables-based policies that are direct, which is a little worrisome, but it's politically understandable. There's a lot of pressure to keep electricity prices low in particular provinces. And that's hampering renewables promotion because renewables are seen as a way of basically causing prices to be higher because it's taking away the potential at the margin for more of the fossil-based fuels, fossil-based generation. So I leave you with sort of the last questions here. Should China resurrect strong direct subsidies to renewables to get there? I'll offer 2 answers. One is, well, no, it'd be redundant. They have these other policies, and we also are indirectly encouraging renewables through the TPS itself. So this is sort of the question of redundancy that previous talks today have already talked about. But then there's also the counter argument that yes, it is justified in the sense that renewables might address other market failures, might encourage learning by doing more. It might encourage, in other respects, technological change that wouldn't occur otherwise. So that would argue for ramping up. So I think a major question going forward is not simply going to be how much the TPS will become more aggressive, will become more stringent, which it will. It's only accounting for small reductions now in CO2. But the other question is to what extent China is going to focus more directly on renewables, something that in some ways it has scaled back on in recent years for political reasons. So thanks for the opportunity.
Thanks very much, Larry. And actually all the presenters, and we're right on time. So I have a few questions that I'd like to pose to different people, and we're getting some questions coming in through Q&A. I'll turn to those in just a few minutes. So let me address the first one to Larry, just following up on your presentation while it's still fresh in our mind. Now you spent a lot of time talking about the rate-based trading system in the form of tradable performance standards instead of cap and trade. And you also mentioned that they had some efficiency problems. Can you talk a little more about why one might actually choose a tradable performance standard rather than cap and trade, as we here in the rest of the world set out to set up our own systems, and Chinese experience can be valuable?
Yeah, sure, Charlie. I also say, by the way, that Chinese planners at least have mentioned that they put under consideration the possibility of morphing to a cap and trade system over some years. But I think there are a couple of reasons. One is that the Chinese are used to intensity standards. Again, their 5-year plans are usually described in terms of intensity. Secondly, the planners are often, hope I'm not insulting anyone out there, but often have kind of an engineering focus. And in a way, it's a little bit easier to kind of think of things in terms of just getting intensities down rather than these newfangled approaches that have no assurance, in some sense, you might think, under cap and trade, what's going to happen to intensities. And then there are also these other reasons. One is that the intensity approach will, because of the implicit output subsidy, it will imply smaller increases in electricity prices. And that can help reduce potential leakage. And it also can have some distributional effects which some might favor, which is to prevent electricity prices from going up as much. And I mentioned that that issue has also helped explain why China in some ways has scaled back on direct subsidies to renewables. So I think for all these reasons, there are attractions. My own feeling is it's a pretty nice half of a loaf. And I think it's a very welcome step. And I've been encouraged that despite a lot of the tensions between the US and China, the Chinese planners are really pushing forward very much on this, very much dedicated to this, and are continuing to take advice from outsiders like myself as to the design. I'll just mention one anecdote. Originally, they thought they would go with 11 different benchmarks, which would be very useful for dealing with fairness or distributional issues. That gives you more flexibility. But more recent research has indicated that if you have that many benchmarks, it's highly inefficient. Now they've scaled it down. They're probably going to go to 3 or 4 benchmarks. So it's very exciting to me that they're committed and that they are taking advice from the international, from others outside of China. That's a really very nice collaboration.
Yeah, we should remember that George Bush, the Jr., first turned to performance standards as a alternative to capping emissions back in the noughties, as Richard referred to them. So anyway, thank you, Larry. Let me raise a question for Richard. Speaking of Richard, as I understand it, the Climate Change Act of 2000, whatever it was, 8, I think, was a bipartisan action by the conservatives and labor at that time to address climate change, and it's widely considered in the UK to be very successful. I wonder if you could tell us why it was embraced bipartisanly and why it's been successful.
I think probably just great good fortune. Party discipline is much stronger in the UK than it is in the States. Members of Parliament do get deselected by their central party, saying you are not allowed to be a Conservative candidate anymore. And so that is, there's none of the sort of, I will stand in the primary and then go my own sweet way if I win the gerrymandered seat. That gives some people a certain degree of independence. And whether it just happens to be the leadership of the parties, the happenstance of individuals, Certainly, there are some politicians, typically those who think Brexit is a good idea, often also think that climate science should be ignored. But the consensus has held, and public opinion also tends to get enough of its information from reputable sources, despite the best efforts of some sections of our media.
Thank you. Thank you. So let me address this to Chris. And President Biden recently, as you know, rescinded the Trump administration's reduction in the social cost of carbon, which makes it now about $51 a ton, more or less, of carbon dioxide. Historically, the social cost of carbon has mostly been used in cost-benefit analysis of new regulations. It has not been much used for operational decisions, such as in fuel choice for electricity generation. So in terms of policy changes, can you see a way to use the social cost of carbon more effectively to incentivize decarbonization?
Well, I think the first use would be through a price on carbon, which would obviously require legislation. But one vision of the world is that we adopt a tax and dividend plan where the tax starts at the social cost of carbon, or at least somewhere close to it, and quickly ramps to it. That, I think, tends to be the most efficient way to get carbon reductions, although there are certainly other market failures that might require additional policies. I'll also point to some recent work by Bob Litterman and Gernot Wagner that, because of risk considerations in their risk model, you'd actually want to start a carbon tax at much higher than the social cost of carbon and get rid of a bunch of risk, and then it falls over time. I like the paper. I think it might paint us economists into even a smaller corner that suggests even a less politically palatable policy, a high price on carbon at first that then falls. So absent a price on carbon, I think it'll start to be used in a cost benefit analysis. If there were a movement to adopt a national clean energy standard, it would be used to calculate the benefits of such a standard. So I certainly see it being used. My preference would be to see it being used as an explicit price on carbon.
Okay, thank you. Thanks, Chris. Steve, I've got a host of questions that I could put to you, but I'm going to just give you one. And there are others will come. But for decades, as you know, coal interests have been the main obstacle to cleaning up emissions, whether it's with sulfur back some time ago, local air pollution, now carbon. And there's very, very understandable reasons for that. And you mentioned those in your presentation. So what can be done to get us over this log jam? Would it be carrots that we can provide to coal industry, or such as helping with the coal retirement fund, or training programs, or are sticks a better way to proceed, or maybe a more effective way to avoid making a value judgment? Sticks like the carbon tax, which of course will hit hard in the electric utility choice of fuel, and put coal down the merit order.
Yeah, so it's a complicated question because there are, but I'm going to answer sort of pragmatically, given all the feedback I've heard, primarily in Congress, just over the last month, in testimony sessions and in briefings. This is one of 4 briefings I'm doing today for instance. So there's just a lot of that of interest in this area. First thing to remember is that it's important to understand that coal doesn't mean fossil, and I know you know that, but everybody should keep that firmly in mind in the United States. The coal job losses that are coming, if the US were to implement the clean energy standard, for instance, and the price on carbon that we recommended, would be immediate. Now, it would also be the case, they wouldn't lose them all, but there's a strong loss in coal jobs almost immediately. And basically, coal electricity is gone by 2030, providing enormous health benefit to the country rapidly that more than pays for the transition. In contrast, oil and gas jobs last longer. You can think of it as a decade of delay. And so there's a chance for policy to proactively address oil and gas jobs in a way that's much more difficult with coal jobs, because coal jobs are already hemorrhaging, right? And so that's a really important distinction. The reason that oil and gas lasts longer is that the transport fleet doesn't electrify immediately for oil. And because as you build out renewable capacity, you need to retain our existing gas capacity to provide a firm source of power, right? As we're, eventually we have to deal with that that firm capacity, decarbonize that firm capacity too, but the gas capacity provides it early on, so there's still demand for gas, right? With coal, it's also regionally specific. So inside Appalachia, there is a special problem that goes back many decades, and for which coal is just one facet. But if you look at, for instance, what Senator Manchin says, who is after all from West Virginia and is the swing vote in the Senate, what he wants is a series of incentives to bring other kinds of jobs into his state. And so this is consistent with the idea that, if you ask, what happens to jobs nationally? Well, more jobs are created during the transition that are lost, but that doesn't help if you're in one of those concentrations of fossil jobs where your community is hollowed out, right? But what could you do about it? Well, most communities see an increase in jobs because wind and solar is, after all, distributed. So most communities gain their economic base and their employment base, but the fossil intensive communities lose. What is untethered? Well, the answer is a lot of industrial capacity, low carbon industrial capacity that we need to build is untethered geographically and could be tethered to proactively address job losses or as part of a political deal, which might in fact even be the same thing. This is relatively easy on the Gulf Coast because CO2 disposal reservoirs are located in proximity, and there's also an embryonic pipeline network to move captured CO2 from industries that would do CCS. It's also conceivable in the northern Midwest through Wyoming. Appalachia, you'd have to make a special case, right? You have to actually build a network. But that's what's being discussed in Washington right now, is incentives to bring industry in.
One thing I hear is that the quality of the jobs is quite different. The ones in the coal jobs in the Midwest are unionized typically, so they're getting pretty reasonable pay, whereas the renewables jobs are basically construction jobs.
Absolutely. And so this is another problem for the coal communities. Now, for those communities that are just gaining net renewable jobs and aren't losing the fossil jobs, that's a net gain still. Our committee spent quite a bit of time on the issue of the quality of the jobs. And so this is one of the reasons why trading industrial jobs for fossil jobs is politically more palatable than saying incorrectly that fossil jobs can be replaced by renewables jobs. There's no location that has substantial fossil employment for which that's true.
Okay, so it's 10 o'clock in California, so let's sprinkle in some questions from the audience here, and I would remind the audience that put your question in the Q&A. We're not able to get to everybody's question because, as you can tell, each question takes about 5 minutes to get through. But we'll handle some of these. So first question is from Adrian Johnson, and I don't know any more about the affiliation of people, and nor their honorific titles, but pardon that. Her question is that some well-intentioned policies, such as net metering, that's when you have solar on your roof, and it's just the net amount of energy you draw from the grid you're charged for. Net metering has been shown to be regressive. What are some of the progressive? This may go to any people, but Steve perhaps in particular. What are some of the progressive federal solutions to be done in the next 10 years, aligned with enough for a 1.5 degrees C goal? Which is, as you may recall, is a possible, well below 2 degrees is what Paris said. And there was no agreement on whether it's 1.5 or what well below meant. But anyway, 1.5 is often used. So Steve.
Yeah, so on the generic question of whether or not US net zero by 2050 is consistent with 1.5 degrees.
Net metering, well, go ahead.
Yeah, the net metering question, I think Chris or Richard should really take a stab at it.
Okay, we'll turn to them next.
I answered that already in the chat, and the answer is, if we're lucky and the rest of the world acts as well, and in the developing world, that might take some level of selflessness. And if we're unlucky, if we're at the upper end of climate sensitivity, then no. But net zero in the US by 2050 is broadly consistent with the statement that the goal should be limiting warming to substantially less than 2 degrees Celsius. It's broadly consistent with that, given the uncertainty in the climate sensitivity. But you are not certain to get to 1.5 degrees with any policy anyone has on the table, given the uncertainty in the climate sensitivity. We've already admitted too much to be certain about that.
Yeah, the uncertainty in climate sensitivity.
You should turn to a policy expert. I'm kind of a climate guy who's chairing a committee of policy experts.
Yeah, I remember the graph in one of the IPCCs of probability density is for the climate sensitivity, and for the doubling of CO2, you could get to 1.5, or you could get to 10 degrees. The uncertainty at that time was such.
Well, it's not as high now, but
not as high now.
You can think about a doubling of CO2 as between 3 and 5 degrees, right?
Yeah, which is higher than it used to be. So it used to be like 1.5 to 4.5, I think. But anyway, let's turn to maybe Chris Knittel. Do you have something to add to what are some progressive alternatives to net metering?
Yeah, actually,
that would be consistent
sure.
with a 1.5.
Well, I'll do the reverse of what Steve mentioned, and I'll punt on the 1.5 and just talk about progressive potential.
Okay, there we go.
Policies. But first, let me just spend 20 seconds beating up on net metering even more. It's actually worse than we think with net metering and the regressivity of it. And it's for 2, maybe 3 reasons. So one is we tend to subsidize rooftop solar. It tends to be wealthy people that put rooftop solar on their roofs. So the subsidies themselves are going to wealthy people. But I've done some recent work with Scott Berger that I could put in the chat that looks at a second effect of regressivity, which is the way we price electricity is we tend to pay for the distribution and transmission systems through a volumetric charge, right? So we charge, say, 6 cents a kilowatt hour to pay for the distribution system, even though that's largely a fixed cost that doesn't depend on how many kilowatt hours or kilowatts are running through the system. But so what that means, though, with policies like net metering and solar more generally, is that when I put a rooftop solar on my roof, I'm getting the full benefit, not just how much I'm saving the system on the energy side, but I'm also getting this volumetric benefit that used to go to pay for the transmission and distribution, and now I don't pay for. But those costs, because they're fixed, have to go to somewhere. So what you have to do now is raise the volumetric charge for everyone that didn't put rooftop solar on their roofs. So what we do in that paper is show the magnitude of that second regressivity effect, and it can be quite large. So one thing that's more progressive that we could do to undo that second effect is to start having larger connection charges for our electricity system. So price energy based on what those costs are, which are a volumetric cost to the system, but price or pay for transmission and distribution through fixed charges or lump sum fees. And then you could even make that more progressive by having that means tested in some way, where low income households pay a smaller connection charge than wealthy households. So that's the first thing. The other thing is that we need to find a way for low income households, many of whom don't have roofs, to share in this rooftop solar phenomenon. And that can operate through more policies for what's called community solar, where low-income households can pay into solar farms and get some of the benefits that the wealthy households are able to get because of all the subsidies for solar.
Okay, that's very, very helpful. In fact, more thinking on those lines might be very, very beneficial and very actionable.
Could I ask just a quick follow-up on that? Our committee discussed at length community ownership of, say, renewable asset. There are a lot of communities that own substantial vacant land, and some of these aren't even rural, like Detroit, for instance. And the idea that a municipality would capture revenue that it would use to fund local government is one that is really quite progressive. And so could you talk a little bit about that? We've looked at policies like that at some length.
Yeah, well, that would certainly, so the advantage of something like that, and the key advantage to utility scale or larger scale solar installations, is the costs are sometimes cut in half, right? So I didn't rail on rooftop solar for that reason, but it's a very expensive way to get solar electrons into the system. So right away, you would get benefits from that. I would certainly advocate a local community thinking along those lines rather than subsidizing rooftop solar, because you would get the community-wide benefits. They'd be more dispersed across the whole community, and you would get the cost savings associated with that.
And poor people get better services out of the deal.
Right.
Although I'd point out that community solar is not always for poor people. My
colleague
in Maine is in a bunch of townhomes with other retired people, and they are setting aside a few acres of their community property for a community solar project.
Yeah.
Because the roofs won't handle it. Okay, so let me have a question here for Richard Green. Actually, anybody, but Richard comes to mind, but it could be anybody else that wants to try it. It's from Repudaman Malhotra. Sorry for the butchering of the pronunciation, but nuclear power plants are shutting down across the world, some due to cost concerns, and some due to public opposition, and many to both. On the other hand, modular nuclear reactors might provide much needed baseload energy supply in a 100% renewable world. I think the main point is innovation in renewable may work out. Maybe it would, maybe it won't, maybe it will. The question is, should nuclear energy be part of the decarbonization process?
It certainly does get you a slug of rather useful baseload. Now, having too much baseload isn't so helpful if you then have a lot of variable renewable energy without storage. but with adequate storage and potentially the ability to ramp down the nuclear stations, which is something that the French have been able to do for years. It's not completely efficient. If you do it too much, it does use up fuel. So there are limits to what you can do, but you can do it a bit. So nuclear can be a useful part of the mix. In the UK, there are definitely a substantial minority of people who don't like nuclear power, but it does tend to be a minority. And we've got one reactor under construction at the moment, and others being seriously considered if only they can get the costs down, and looking at different contracting arrangements to try to reduce the risk and the cost of capital. So it's certainly part of the mix being used in Britain.
Yeah, the French are very behind nuclear power. The Germans are opposed to it. So it's a very, very heterogeneous picture, I think.
Absolutely.
Anybody have anything else they want to add to that?
I guess
Okay,
only that
go
most proposals for getting to net zero do try to extend the lifetime of our existing nuclear fleet, even if the destination is 100% renewable with no nukes in the end. In other words, those nukes, once you build them, are cheap to keep running. And if we can extend their lifetime, that's an asset.
Yeah.
The only thing I would add to that is, and with a bunch of economists on, I'm sure we'll all agree that we really want a level playing field. And if nuclear can compete, which, we haven't been good at building nuclear, but other countries have, then we should allow it to compete. So we shouldn't build a system that somehow penalizes nuclear. It's certainly, the Fukushima accident was a catastrophe, but I often try to remind policymakers of the thousands of coal mining deaths associated with all of our coal power. So nuclear has both carbon benefits for sure, and potentially health benefits.
Fully agree.
Go ahead, Larry.
Fully agree with the goal of leveling the playing field. But what makes it especially difficult in the nuclear case is it's not always easy to know what's level. It's so difficult to assess the risks. Not a disagreement about that.
Yep.
That's very true. It's very true. But we should also remember that, and this is an agnostic statement, that when we talk about nuclear, we tend to think of the design that was in the US that was perfected in the 1950s. Because the last nuclear power plant that was ordered was in the early 1970s. But technological change and innovation could change what we think of as a nuclear power plant, or maybe not. But perhaps the aversion should be to the nuclear power that we know, and not necessarily to what may come in the future, if we're going to have an aversion. Okay. Let me turn to a question by Martin Homek. We might expect to see a change in living and working conditions caused by the COVID pandemic or some other concerns. I think we're all wondering, what's going to happen to cities once people fall in love with Zooming, although I'm sure we'll all be glad to put Zooming aside once this thing is over. But we don't know what's going to happen. So the question is, do you think these changes may affect distributed energy resources, electric vehicles, transmission expansion policies, other things we're talking about, which are sort of based on the way we've seen the world pre-COVID? So anybody want to take a shot at that? Larry, you got a smiling face.
I just say the one obvious dimension where I think there'll be a big change is the boondoggles that we academics take to do a lot of international level. I think we've learned that we have to admit that it's a little bit hard to justify the carbon footprint of a lot of our travel. And air travel is a major contributor to CO2 emissions. It may not just be from academics. I think there's going to be a significant reduction there. I don't have the estimates as to what might be the extent, but I think that'll be one channel that where the footprint is much less than what we would have predicted a year or two ago.
Yeah, the only one I would add to that, and that's a great point, Larry, but in principle, electric vehicles have a big upfront investment and then a smaller marginal cost of driving. So electric vehicles are more attractive the more miles you drive. And if we're actually doing more telecommuting and not driving as many miles, of course we could downsize the batteries, but that doesn't work for the weekend trips as well. So it might be, it might reduce the diffusion of EVs. I don't think it's going to be a big effect, but directionally, I think that's the way it would go.
EVs, I think, are betting on innovation, reducing the cost of batteries. Everybody that drives an EV thinks they're terrific, just expensive. And so far, the innovation in energy storage is a bright spot on the horizon, not only for end users, but also for utility storage. So let me ask another question from, this one is from Jeff Byron. I think it's to Richard. And congratulations to the UK for an extraordinary reduction on CO2 emissions in such a short time and for providing an excellent example for other countries. Hopefully ones that have a coal industry you can get rid of. The Green Staffel paper is excellent in analyzing what has transpired. How much of the CO2 reduction do you think is directly attributable to policy changes versus market forces? That's a great question.
Well, thank you very much for the comment. If I may, I'll just share my screen there and jump to the key slide. So we've got 110 million tons roughly to explain. 40 million tons of that was subsidized renewables, wind, solar, and biomass. And I've just realized I'm not showing you the pointer, wind, solar, and biomass. 20 million tons came from the carbon prices, and 10 million tons came from dealing with sulfur emissions. So that's a total of 70. Fuel prices gave us another 10. So that's clearly not a policy change. Fuel prices are set in world or at least European markets for coal and for gas. And then demand was about 20 million tons. And that's some unknown mixture of policy to reduce demand, the impact perhaps of higher carbon prices, working through demand elasticity, but overall the wholesale price didn't change that much in this period. Possibly renewable subsidies would have pushed demand down a bit, but I would say, this isn't a paper that goes all out on we want to get the causation, I'm afraid. This is just attributing or sort of looking at the effects of these actual changes rather than some of the things that drove those changes. But I would say 70 out of 110 is pretty clearly policy changes that wouldn't have happened if we hadn't had those policies. Thanks. And thank you very much for the comment.
Thank you. So we have another question here from, this is a question from several people, Alessia Kochetkova and Gianluca Rimini. How can we develop an effective and reliable CO2 accounting system that allows us to embrace a sufficiently large share of a different set of activities and processes related to our consumption? We hear often the solution to climate change is to make everybody a vegetarian. So but that's an example of a change in consumption. What can we do to address changes in consumer preferences. So that's a rather difficult question to address. Would anybody like to tackle it?
Well, I'll just say two things. One is that one thing that's nice about CO2, believe it or not, or carbon emissions, is that in most cases, you know how much emissions will come if you know what the carbon content is of the original fuels. So therefore, an upstream carbon tax, which is relatively easy to administer, you put the tax on at that point in the supply chain, then in some sense you have created the needed changes in downstream prices to change consumer behavior. So it kind of handles the accounting to some degree, or to a large degree. The supply chain doesn't always work that way perfectly, but I think to a first approximation, that's a really nice attraction of carbon taxes, the proportionality of carbon content to ultimate emissions. But the second thing I want to say is, I think in the question, there was a point, or maybe Charlie, you mentioned it, about changes in preferences. And there really is an issue of changing norms, which goes beyond policy. Government can perhaps do things through information to change individuals' preferences, so that conditional on whatever policy might be in place, there still is an even greater tendency to make substitutions or changes in living standards. We've seen examples of that in the past. To a large extent, the change in norm toward recycling, where it's now a habit by so many households, vast majority of households, isn't directly due to changes in prices or policy, but rather it's become a change in norms. So I do think, as a complement to the kinds of policies that we've been talking about today, there is really the issue of information and job owning, which hopefully can also engage the norms channel.
Thank you. So we have another question from Jeremy Platt. This is to Chris. The hockey stick, which you mentioned, seems to have been missing from setting a CO2 reduction goal. Might less ambition bring far greater social benefit, participation, both nationally and globally?
Yeah, so this links to the discussion we had about the social cost of carbon. If we knew the social cost of carbon, then that would tell us how far up that marginal abatement hockey stick curve we should go. Whether or not these 100% decarbonization goals are aspirational or real goals is actually going to be the topic of a webinar, a CEPR webinar in a couple of weeks. I like to somewhat joke, but somewhat seriously say that rarely is 0 and 100% the right answer. Usually there's some interior solution. So I don't know, it's certainly the case that in some modeling work that we've done at MIT, those last few grams of CO2 that you're squeezing out of the CO2, out of the electricity system, can cost $1 million a ton, right? In some of these model runs. So I do think as we approach 100%, the society or policymakers are going to have to, think hard as to how far up that hockey stick we want to go.
Could I come in?
Yeah, go ahead.
The UK target talks about net zero for that very point, that the last bit of decarbonising various things will be very difficult. And although I'm certainly enjoying having less jet lag than the last time I talked at Stanford, the aviation is one of those things. And therefore, if we can use biomass with carbon capture or other technologies to take carbon out of the atmosphere, that allows some residual emissions. I think the problem with anything except zero is that my limited understanding of the physics is, if it's not zero, it just means we get to move Miami a few decades later, which might be that the postponement is felt worthwhile by us. I don't know about the people a few decades later.
Also, it's useful to point out that net zero goals for the globe by 2050 using current IPCC global warming potentials will actually result in falling atmospheric CO2 concentrations because the land and ocean sinks continue to operate. And also in a cooling planet, particularly as the methane emissions equilibrate to a new lower level, right? And so, because methane's short-lived, so it equilibrates, doesn't build up, right, in the same way. So the temperature goals already include cooling forcing in the planet, all right? And so weakening them further leads you, towards Miami underwater in the way that you just described, right? It's already really stringent. In other words, net zero by 2050 is not net zero change in forcing, all right? That's the point.
Okay, we have about 5 minutes left, and I have a couple of questions. So let's see if we can get to the two of them. Steve, outside of the U.S. and including the U.S. and Europe, NIMBY issues and other obstacles impede renewables and new transmission. What public policies can remedy this?
Yeah,
how do you solve NIMBY?
Yeah, I mean, I actually believe that this is where the consumer preferences matter the most, right? It's in opposition to the massive transformation, for example, of the landscape that we're talking about. Our group took a substantive look at decreasing US demand for energy services and decided that it was impractical. Okay. I mean, other than and that's why except forcing people to buy heat pumps with a manufacturing standard and the electrification of the vehicle fleet is just, it's electric cars are better, they're faster and everything else, right? But in general, if you ask an American to do with less, I think they get mad at you, right? But on the other hand, I think that public opposition to projects is serious, and the baked-in Byzantine regulatory and permitting structure we have, particularly for electricity transmission, but also for projects in general, is prohibitive. So we propose a whole series of very granular changes in the way that permitting and regulation is done, particularly of the electrical system. And these include some very, very difficult politically legislative changes in the National Power Acts. There are two big power acts that actually need to be amended, we think. And to transfer, for instance, to FERC, right, which is an agency that does this sort of thing, the authority to plan interstate transmission routes, for instance. I think without that, we're in trouble, frankly. Or I think we end up with a system that costs a lot more, all right? And also that Greens certainly would oppose, right? Because you don't get as much renewable electricity. So I'll leave it at that. Outside the United States, I don't know about consumer behavior so much, but I think that there is some substantial evidence that the nature-based solutions, the land side, the sinks that we were talking about, which are sort of 20% of the whole solution, and a lot of it concentrated in developing countries, that their land tenure practices are much more, and sort of traditional practices that govern the way land is used, make the response to incentives, economic incentives, extremely difficult to predict. I think most people who study this don't think we know how well price incentives will be adopted in these countries.
I'm glad you addressed the NIMBY problem, because it's been with us for a long time. I remember in Spain, a lot of opposition to siting windmills on the top of ridges around the country. So I think it's in a lot of places. Well, we've run out of time. Let me thank all the presenters and the audience. So just closing, it's now 10:30 in California. I just wanted to say that in 2 weeks, March 31st, we have another webinar focusing this time on storage. A big group of people at Stanford, particularly in the engineering side, working on storage. This webinar will be moderated by William Chu, material science, and will be the same format as we had today, but a different topic. But thank you everyone for joining us, and have a wonderful rest of your day, or sleep well. Thank you.